example 2, solve for n if np2 equals 30, where n is a natural number. So we're going to use this formula right here, and we're going to plug n in for n values and 2 in place of the r, and it's going to equal 30. So it's going to look like this. Normally I'd write the formula out again, but it's right there for us. So we're going to plug in n factorial over n minus 2 in brackets factorial, and this is going to equal 30. Now I need to cancel out those factorials, so I'm going to count down this n, and we're going to keep counting until we get to the n minus 2, and we leave that factorial symbol there. And we count that down. The equals 30 must be here as well. Our equation has to stay there. It can't turn into an expression again. And we've got this. So now I have n squared minus n equals 30. And now you have a quadratic to solve for. So n squared minus n minus 30 equals 0. We're going to set it to 30, or to 0 rather, by moving the 30 over. And now we're going to solve. Remember the equals 0, so that you still have an equation. So two numbers that multiply to 30 add to negative 1. So you're going to get n minus 6, n plus 5. So n equals 6 and n equals negative 5. Now, n has to be a natural number. That may not be written in your questions. You need to know with permutations that n must be a natural number and also must be greater than the r value, and negative 5 is not greater than the r value. So we would reject this answer. So our only answer is n equals 6. Now, you don't need to explain why you're rejecting in your questions, but I want to, in our notes, to sort of say that the two reasons are n must be greater than or equal to r, and n must be an element of natural numbers. So this sort of breaks both those rules. So even if n equals 1, 1 is a natural number, but 1 would have been less than the r value, you would have to reject that as well.